Today we're looking at problem 18 from the 2025 AMC 10B competition, where we're trying to find the ones digit of this sum. The square root of the floor of the square root of 1 plus the floor of the square root of 2 plus the floor of the square root of 3 all the way to the floor of the square root of 2025. And the idea is we can actually evaluate this sum directly, right, by counting how many times does 1 appear in the sum, then how many times does 2 appear in the sum, how many times does 3 appear in the sum, all the way to, I guess in this case, we have that the square root of 2025 is equal to 45 squared. So we only have to consider up to how many times does 45 appear in this sum. And so sort of trying it out, how many times does 1 appear? It appears as, this floor of the square root of 1, the floor of the square root of 2, the floor of the square root of 3, and that's it, right? Because then the floor of the square root of 4 would jump up to 2. So in particular, these are just the numbers between 1 and 3. So similarly for 2, we have it is equal to the floor of the square root of 4, the floor of the square root of 5, the floor of the square root of 6, the floor of the square root of 7, the floor of the square root of 8, and the floor of the square root of 9 would equal to 3. So these are just the numbers from 4 to 8. And so we can sort of generalize this. For 3, for example, will be the floor of the square root of 9 all the way to the floor of the square root of 15. And so this will be from 9 to 15. And so we can note that, for 1, the number of times 1 appears is the number of numbers from 1 to 3, which is 4 minus 1. The number of times 2 appears is 9 minus 4, right? The total number of numbers from 4 to 8. And the number of times 3 appears is the total number of numbers from 9 to 15, or 16 minus 9. And so we can rewrite this as 2 squared minus 1 squared, 3 squared minus 2 squared, 4 squared minus 3 squared. And this makes sense, right? Because the only times a certain number will appear, let's say 3, is between 3 squared and the next number squared, or 4 squared. And so then there will be a total of 4 squared minus 3 squared numbers that equal 3. And so we can continue this all the way to 44, right? We'll have some number of numbers, but in particular we'll have that we have 45 squared minus 44 squared times, or 44 appears, and then 45 will only appear one time as the square root of 2025. So now we just have to evaluate this sum, right? We have 1 appears 2 squared minus 1 squared times, plus 2 times 3 squared minus 2 squared, plus 3 times 4 squared minus 3 squared, all the way to 44 appears 45 squared minus 44 squared times, and then plus a lone 45. And so this doesn't seem too easy to evaluate, but you see that there's like a bunch of shared square terms, right? We have a 2 squared here, 2 3 squares here. And so if we expand it, hopefully a bunch of terms will sort of cancel out and it'll make the sum easier. So we have 1 times 2 squared minus 1 times 1 squared, and then plus 2 times 3 squared minus 2 times 2 squared, plus 3 times 4 squared minus 3 times 3 squared, plus 4 times 45 squared minus 4 times 44 squared plus 45. And so you see, like, sort of diagonally, these will sort of cancel out. So this will be equal to 1 times 2 squared minus 2 times 2 squared. Well, first we'll have a minus 1 times 1 squared, and then 1 times 2 squared minus 2 times 2 squared. That's minus 1 times 2 squared. And then 2 times 3 squared minus 3 times 3 squared. That's another minus 1 times 3 squared. And again, this will generalize and keep going until we have I guess these should be 44. Minus 1 times 44 squared plus 44 times 45 squared plus 45. And so now we just have that this is a sum of squares, right? This is equal to minus 1 times 1 squared plus 2 squared plus 3 squared all the way to 44 squared plus 44 times 45 squared plus 45. And so the formula for the sum of squares is, if we have sum of n is equal to 1 to m of n squared, this is equal to m times n plus 1 times 2m plus 1 over 6. So for our case, we have m is equal to 44. So this is negative 1 times 44 times 45 times 44 times 2 plus 1, which is 89 over 6 plus 44 times 45 squared plus 45. And remember, we want to find the ones digit of this sum. So we only care about the ones digit, right? So I guess going from right to left, so it's easier. This 45, we only care about its 5 in the ones digit. This 44 times 45 squared, note that 44 is a multiple of 2 and 45 is a multiple of 5. So the entire product is a multiple of 10, so it ends in 0. And then for this term, we have that this can factor as we divide by 2 from 44 and 6, and we divide from 3 from 45 and 6. And so again, this product, we have a multiple of 2 and 22 and a multiple of 5 and 15. So this product will be a multiple of 10. So that we just minus 0 from this one. And so adding this up, we get that the units digit is just 5 for our sum. And yeah, that's it.